Hello and welcome to the new session of electronics. Myself Sham Gore from DSM College, Jintur. Today we are going to see about the proportional current formula. So let us see the proportional current formula. Before going towards the proportional current formula, first of all let us see the parallel circuit. Here this is the parallel circuit. Okay. In this circuit, the two resistances are connected side by side across the single voltage source. So, the parallel circuit is a branch arrangement in which two or more resistances are connected side by side across single voltage source. The parallel connection are also be known as multiple connection, or it is also be called as the shunt connection. So, this is the parallel connection. And some important features of the parallel circuits are the voltage across each component or each branch is the same. Means voltage across this branch means the voltage across R1 is same as the voltage across R2 because only single battery is connected across these two branches or across the two resistances, and therefore for the same voltage, if we want the same voltage across the component, then such types of the circuit arrangement is used, that is the parallel circuit. We need when we need the same voltage across the each component, then such type of the parallel circuit is used. This is the first feature of the parallel circuit. Second feature is reciprocal resistance formula. Here the resistance of this parallel circuit is less than the individual resistance of the circuit. And according to the reciprocal resistance formula, reciprocal of the net resistance or equivalent resistance of the entire circuit is equal to the sum of reciprocal of the individual resistance, means 1 divided by R. R is the net resistance of the total circuit or the total resistance of the circuit, and here reciprocal of the net resistance is equal to reciprocal of the individual resistance, means 1 divided by R is equal to 1 divided by R1 plus 1 divided by R2. This is the in reciprocal resistance formula. Okay. Now let us find out the current flowing through the each branch. Here there are the two branch between the point A and B. The two resistances are connected. This is the first resistance R1 of the 2 kilo ohm. Second resistance is R2 of the 8 kilo ohm. And here the voltage across the point A and B is equal to V, and the total current is equal to I. Okay. And when this current comes at a point A, some current is flowing through this branch, some current is flowing through this branch. Means in these branches, the current is proportional to the resistance. If the resistance is less, current is more, and if the resistance is more, current is less. Means the current is inversely proportional to the resistance. Hence, let us find out the current flowing through the each branch, and that can be find out with the help of the proportional current formula. And here the current flowing through this branch I1, we know that the current is equal to voltage divided by resistance, and voltage across this branch is equal to V. Therefore, I1 is equal to V divided by R1. R1 is the resistance of the first branch. Okay. So, I1 is equal to V divided by R1. V. So, first of all, let us find out the V. Okay. V is the voltage across R1, and V is equal to I into R. I is the total current, R is the total voltage. Okay. So, here the value of R is equal to 1 divided by R is equal to 1 divided by R1 plus 1 divided by R2. Okay, and let us substitute the value of R in this equation. If we know 1 divided by R, we can find out value of R. So here I1, that is the current flowing through the first branch, is equal to I, this is the I, into value of R. R is equal to R into R2, R1 plus R2 divided by R1 into R2 divided by R1, and therefore I1 is equal to R2 divided by R1 plus R2. This is the current flowing through the first branch. Okay. Similarly, the current flowing through the second branch, this branch is equal to, that is the I2. I2 is equal to I, that is the total current I into the opposite resistance R1 divided by total resistance R1 plus R2. So I2 is equal to I into R1 divided by R1 plus R2, and this is the proportional current formula. Similarly, I1 is equal to I into R2 divided by R1 plus R2. So this is the proportional current formula. Similarly, for this circuit, let us find out the current for the this parallel combination. Here the current I1, okay, I1 is flowing through this branch, and I1 is equal to, total current is 6 ampere. So the total current into the opposite resistance is 8 kilo ohm. So 8 divided by total resistance 2 plus 8 and therefore I1 is equal to 4.8 milliampere. Similarly, the current flowing through this resistance or second branch is equal to I2. I2 is equal to 6 into 2 divided by 2 plus 8, and that is equal to 1.2 milliampere. So this is the proportional current formula. If you want to find out the current flowing through the any branch in the parallel circuit, we can find out the current with the help of such formula, and that formula is the current proportional current formula. Okay, so this is the current formula, that is the proportional current formula. Thank you for watching this video.